Every January, a highly coordinated logistical operation unfolds on American hives. Commercial beekeepers load thousands of hives onto flatbed trucks and rush them across the country under heavy netting. Two-thirds of U.S. commercial honeybees are funneled into California's Central Valley to pollinate 900,000 acres of almond trees, generating over $30 billion. This entire agricultural engine depends on a specific wooden box designed in the 1850s. For 10,000 years, the act of harvesting honey was a zero-sum game. If a human wanted the sweetness inside a hive, they had to confront the defensive instincts of a colony that had spent months building it. Historically, humans used sulfur smoke to kill the bees, or simply smashed the structures apart to get to the wax and honey. In almost every culture, the harvest effectively destroyed the hive. We relied on the bees' resources for food and light, but we lacked the technical means to manage the insect without killing the colony. Ancient Egyptians attempted to manage this by building pottery tubes and stacked jars along the Nile. These allowed for some organization, but the internal workings of the hive remained out of reach. By the Middle Ages, European monasteries became the centers of beekeeping to supply the church with pure beeswax candles. They used skeps, upside-down baskets woven from straw or wicker. The problem was that the bees attached their honeycomb directly to the walls of the skep. It was a black box. A beekeeper couldn't check for disease or harvest honey without cutting the combs out and ruining the hive's structural integrity. These methods traveled to the American colonies in the 1600s. Hives were essential frontier livestock, often managed by women, where the resulting beeswax served as a physical currency for bartering. Despite centuries of practice, the economic bottleneck remained the same. You couldn't scale an apiary if every harvest required killing off your own biological stock. The solution arrived in the 1850s through Lorenzo Langstroth, a minister and obsessive observer of bees. He realized that the key to managing bees wasn't force, but architecture. Langstroth identified what is now called bee space. He noticed that bees instinctively leave a precise 3/8 of an inch hallway between their combs. Any space smaller is glued shut with resin. Any space larger is filled with extra wax. He engineered a wooden box with hanging frames suspended exactly 3/8 of an inch from the walls and each other. Because the bee space was respected, the bees built their combs strictly inside the frames and refused to glue them to the box. A beekeeper could now lift out a single frame of honey, shake off the bees, and replace it without damaging a single cell. This was paired with the bellow smoker, which used cool smoke to mask the colony's alarm pheromones. Together, these tools gave humans safe, repeatable access to the hive. With these inventions, beekeeping transitioned from a destructive backyard chore to a scalable industrial science. Langstroth's standardized box allowed hives to be stacked and moved with ease. This birthed the era of migratory beekeeping, where colonies are treated as mobile industrial assets. In this modern system, honey is a secondary product. The primary revenue comes from pollination contracts, where beekeepers are paid to bring their workforce to specific crops during their bloom window. These standardized boxes are dropped directly into massive single-crop monocultures. For a few weeks, millions of bees work a single species of plant before being loaded back onto trucks for the next destination. This industrial pace carries a biological cost. The bees face constant travel stress, regular exposure to agricultural pesticides, and a nutritional deficit from eating only one type of pollen for weeks at a time. When millions of bees from different regions are concentrated into these areas, they create a massive flu clinic for honeybee pathogens. The result is a series of systemic failures, often labeled as colony collapse disorder. By standardizing the hive's architecture, we successfully integrated the bee into our industrial food chain. But the current rate of colony failure suggests we have reached the limit of what this organism can endure.